Welcome to this lesson. And in this lesson and the subsequent lessons, we shall be treating a new topic altogether. A new topic altogether. You remember we talked about the types of motion. And we mentioned linear motion, translational motion, particle motion, wave motion, translational motion, circular motion, rotational motion, and the rest. But we have chosen one of them to treat, and that is simply circular motion. So we are going to look at then two things are happening here. The motion are described as circle, and that circle has a center. Now the fact that the motion has described a circle means that we are going to look at two types of motion over here. One is called the circular motion, and the other one is called the rotational motion. All right? Now, this circle has a center. Now, if I should draw a straight line through the center into the board, a straight line through the center into the board, I'm going to call that straight line an axis. So you see, I'm going to interchange center and axis in the course of our deliberation. So that is the center, the circle for you, and the center. Come on, let's put the center at its right position, and the center will be somewhere here. I think so. Right. Now, let's look at what is differentiating between the circular motion and the rotational motion. I'm going to take this as a body moving to describe this circle, and watch it. The body is doing this. Can you see that? And it is describing the circle. And where do you find the center? The center is right inside the body. You can see it. I will take the body away, and this is the center. And the center is found right inside this body. So we have the body moving to describe a circle, and the center of the circle, or the axis, is found within the body. Such a motion is what we call rotational motion. Rotational motion. What about this? The same duster moving to describe a circle. This time, watch it. Can you see that? It is moving to describe a circle. But where is the center? The center lies outside the body. Now, if the center lies outside the body, then we shall call such a motion circular motion. That is the clear distinction between the two, even though the two motions are all describing a circle. And therefore, if you have a body moving in a circular path, and the center lies, the center of the circle described lies outside the body, then we shall call that circular motion. And that is exactly what we are going to treat. Circular motion. I'm going to do some demonstrations for you. And to start with, I have a car with me here. A car. And this car is supposed to negotiate a bend. Now watch this. The car moves along this part of the circle. Now let's assume that the car decides not to complete the circle, but will join a route and then leaves this way. What it means is that the car only moved along this part of the circle, and that is a curved path. It is not a complete circle, and yet we consider such a motion circular motion. You might think that the circle must be completed before we can consider that a circular motion. But let's look at this. The car could move along this path, and we shall call this path a curved path. Look, can't we complete the circle out of it? We can do so. And what we do is to complete the circle. Complete the circle. Complete the circle. And here we are. So even though what the car performed was just part of the circle, we can complete to have a circle with a center, and the car was somewhere outside the center of this circle, and therefore we can consider this path or this motion to as a circular motion. We haven't finished. Let's look at another example where we can take a pendulum. You know, a pendulum is a rope with a load tied to it. That's what we call a simple pendulum. Now we are going to use this one again to demonstrate circular motion. Demonstrate circular motion. Now look at it carefully. Carefully. Do you see what is happening? The bulb, which is hanging on the rope, is going along a circle. Is going along a circle. And therefore we can say this bulb is performing a circular motion. What about this? What about this? Again, the bulb is performing circular motion. The bulb is performing circular motion. So you see, from the demonstration that you saw, it means that a body can go on a curved path or along a complete circle where the center of the curved path or the center of the circle lies outside the body, and that could be considered circular motion. Now we want to look at examples of circular motion. Now we can talk about a car negotiating a bend. we are looking at some examples of circular motion. The first one is a car negotiating a bend, and you saw it. Once a car decides to negotiate a bend, that car performs circular motion. Now, taking the moon and then the earth, we all know that the moon goes around the earth. This is the earth, and this is the moon. And the moon is going around the earth. Where is the center of this circular path performed? The center is found within the earth. But you see, because we are looking at the motion of the moon and not the earth, it means that the moon lies outside the center. And be very careful. The moon lies outside the center. And so the moon is performing circular motion around the earth. The moon performs circular motion around the earth. The third example is to take the sun and the earth. And we all know that the earth goes around the earth, performs circular motion around the sun. The fourth example has to do with the structure of an atom. The structure of an atom. And we all know that the atom has a nucleus, and then surrounding the nucleus we have electrons. I'm going to take just one of them. So I have an electron, this one. What is happening? This electron moves around the nucleus. It moves around the nucleus, describing a circle where the center of that circle described lies outside where the electron is. So you see, the electron is performing circular motion. Interestingly, the fifth example has to do with in the field of aviation. When an airplane is about to land, the airplane will take this path until it lands on the tarmac. This is the tarmac. The airplane will take this, will describe this path. You may ask, but this is not a circle. We are not talking about circle as a whole all the time, but we can talk about part of the circle. Why? Because if you should complete the circle, just using this path taking, if you should complete it, we shall have a circle with a center somewhere there. So it means that the plane in landing also performs circular motion. And incidentally, student, we have treated this also as a projectile motion. So you see, we are putting things together. The plane performs projectile motion as well as circular motion. Look, even when the plane is about to take off, this is what happens. This is the tarmac. It goes straight into the air and takes this path into the air. And this, from this part of the motion, it is part of a circle. And when we complete the circle, we shall have a center somewhere there. And therefore we can say that when the plane is also taken off into the air, it performs circular motion as well as projectile motion. Look, if you happen to have an instrument they call the mass spectrometer, this mass spectrometer has an area where there is a magnetic field. Let me take this area of the instrument we call the mass spectrometer. Now, this area has a magnetic field. Magnetic field. Anytime a charge enters, a charge body enters, or we can say an ion enters this area, the magnetic field will exert a force on it. And what happens is this. This ion will now take this path. It will take this curved path. And again, performing circular motion. If I have a body tied to a rope, I have a body tied to a rope, and I whirl the body in a circle. You whirl it in a circle. It can be a horizontal circle or a vertical circle, as you can see. Right? This body is performing circular motion. So we have a lot of examples to give, and I will leave the rest for you to do it. I will see you again. Bye.